Okay, welcome everybody. It's my big pleasure to introduce our speaker tonight, Marcello Costa. I'm going to take 38 years to put together this introduction because I'd like to go back to the 1980s when I was working in London as a very junior postdoc. My contract was coming to an end and I wanted to move to a really good lab. And the place to come for working on the enteric nervous system was here at Flinders, the lab run by Marcello Costa and John Finesse. I got out here, so excited when Marcello offered me a position for a couple of years. Came out here and discovered that there were other people here as well interested in the autonomic nervous system. There's John Chalmers' group, Ian Gibbons, Bill Blessing, John Willoughby, a plethora of wonderful researchers, all concentrated in one spot. It was a fantastic place to work. And it's very fitting that we're here tonight in the Horseshoe Seminar Room on a Tuesday evening, because for the first 25 years that I was here, we would religiously attend the Horseshoe Seminar meetings of the Centre for Neuroscience after work on every Tuesday. And they were vigorous meetings. The last thing that I wanted to say was that I had 3.5 years as a postdoc working with Marcello, then I got a couple of fellowships, and then became head of department and Marcello's supervisor for the last 15 years. Now Marcello's been here for over 50 years and continues to contribute. And the thing that brought me to Australia was Marcello's reputation in the field. And I can tell you that in the intervening 37 years that I've been here, he's not been sitting on his hands. He's been leading innovative research projects, looking at the circuits that control the motility of the gut. Some quite astounding findings, and that would be pretty good by itself. However, just to dangle a little surprise in front of you, Marcello's been suggesting for the last couple of years that maybe some of the organisational principles of the enteric nervous system and gut motility can be applied elsewhere, maybe to the spinal cord or the brainstem. He's going to put together a huge amount of research work, a great deal of reading of philosophy and science, and we have a real treat in store for us. Now, this seminar is broken up into 4 parts. It's going to be done as a kind of an interview in which I ask some questions which are perhaps not entirely spontaneous. So we'll get on with it then, and this is Marcello. Everybody knows him. I don't need to say any more. Okay, so Marcello, you've been saying to us, certainly I've heard it many times in the lab, that you intend to write a book about everything. Can you explain that, please, and tell us what it's about and who it's for?
Okay, well, indeed, it's true. Thank you very much, Simon. First of all, thank you all of you for coming. It's nice to see many familiar faces, even some less familiar. Perhaps I forgot you, but perhaps I never met you, all of you. It's a privilege to be in this Horseshoe seminar, as indeed Simon mentioned, because when we planned, I was part of the building. This building wasn't here when I arrived, just started. And we decided to design this room in a style that Laurie Geffen agreed was similar to the Greek style of talking. Not a lecture, a place where people could converse. And for many years, we sat directly on the steps. Then I think as we grew older, chairs grew out of nothing. Well, in a way, you're right, Simon. When I started in my career, so to speak, it was working before, by the way. My science career started really a long way back, when I was a very young teenager. And if you manage to get to the first slide, no, that's fine. Yeah. I really wanted to identify the steps necessary to resolve what appeared an unbridgeable gap between the physics of the external world and the physics of the internal world, the minds. This gap, well known in philosophy as dualism, two worlds, one formalized by Descartes in early mid-1600s, separating what he called the objective world, the res extensa, the extended world, and the subjective world, the res cogitans. And when I was in my early teenagers, I just could not accept that. And I decided that sooner or later I wanted to investigate how to bring back these two worlds in a single one. I still think that we live in just one world, not two, not 10, not to 15, just one. At the time, it still doesn't work.
No, it's not going to.
You're going to stand up there all the
I'm
time?
going to stand up here and change it.
Okay, next one then. My family reminded me that I sold my bicycle to buy my microscope. I still got it here, by the way. At the time, I was curious to understand how the world was, how it was made of. And I started to do painting. When I was 12, I was traveling between Buenos Aires, Argentina, where my family moved in 1949, and back to Turin. I was reasonably well known as a young painter, and you can see here in the square of Turin, I still got the painting here in Adelaide. And the next one, in a trip going to West Europe, clearly my mother organized that I would make an exhibition. I was 12, 13 at the time. That was the Atlantic Ocean, and so the captain, and here all my paintings. I was painting there on my own, and so I became reasonably good in painting, and I discovered in a way the nature of space by myself rediscovering what was discovered in the middle, during the Renaissance, the geometrical perspective, the way to transform what we see in geometry, and so we can know what we can see from anywhere without necessarily being there. And that has allowed Galileo Galilei and Newton and Einstein to continue the proper physics. And of course then I became, as I said, reasonably proficient. And this on the right here is this work, by the way, is my very last painting. I was during a trip I was 16, and I stopped painting. You see, this perspective is fine, but this was a trip, and we just went through Barcelona, and I visited a museum of Picasso, and there I saw that he was painting this whole things in perspective when he was 5. In addition, he was painting, when he was my age, a huge story of the marriage of his sister in a style like the Renaissance. And I could not paint faces, human faces. And I told myself, someone that claimed to be a painter cannot paint faces, shouldn't be. So I decided not to continue in painting. Those of you that would dare may be able to see 8 lectures that I gave over the years, and I put them together on the history of painting from the very beginning of human species all the way to present, linking to science and to the brain. But I was interested in the brain because I realized I wanted to know how the brain works if I wanted to overcome this divide between the mind and the world. I was lucky enough at the end of the 1960s to meet Jeff Bernstock, then professor at zoology in Melbourne, at a meeting in Venice. And I asked him whether he would accept me as a student. At the time they published already with Graham Campbell and Max Bennett articles in the Handbook of Physiology. So I realized that was a good place to be. A month later he sent me a telegram saying, Marcello, I found for you a postdoc position for 18 months to come to Melbourne. Well, I went to my girlfriend, Daniela, and I asked her, I told her, well, we got this invitation, do you want to marry me and come to Australia with me? We did. Well, that's Daniela there. Oh, nice working. Oh, what was you?
That was me.
Daniela, of course, that's me. Some of you know John Furness, who I met the very first day I arrived in Australia, Melbourne. I was guest of John Burston. In the afternoon, I went to the lab in zoology, and John Furness confronted me saying, Marcello, I read your papers in Italian and French. You're claiming such and such. I don't believe you. We did the experiment the very same day. And for once, maybe the last one, I was right. So we worked for the next almost 20 years. And I think much of my legacy in science is due to working with him. And then, of course, at the time, we studied the internal nervous system, the innervation of the intestine. This diagram I drafted, but was actually done here properly by a proper artist of Flinders. I believe you got the original. Yes, you do, because I've seen it. But important, this has become so widespread around the world that for decades I was quite upset when they did not quote us. And then I realized, well, of course not, because it's so well known that it doesn't need any quoting. So this has become, in a way, the kind of official way of seeing the vital lives of the gut. Then something happened, of course. Someone mentioned to you that he turned up, and in a way, it was really quite a change in my life too, by the way. He brought not only a superb science, he tried desperately to teach me the proper English, which is still fine now. and together we've done quite well, from the late 80s until quite recently. And so I owe him and many other people since, of course, a lot of what I've done in my practical science. We began to produce some diagrams of the pathway within the intestine, the ascending pathway, the descending pathway, the nature of the transmitter, receptor, and so on and so forth. This was part of if you like to say, the dreams of neuroscientists trying to merge different methodologies and put them together. And I think we were at Flinders among the first one we did, the so-called multidisciplinary. And that was one reason for me to come to Australia, because in Italy, like in many other parts of Europe, the disciplines were absolutely separate. I did not have permission to go and learn electrophysiology, being a lecturer in anatomy. And I had to escape to go to pharmacology. So in a way, I was very, very limited by that side of philosophy. So when I came to Australia, particularly in Melbourne zoology, the system was quite open. And so we moved here at Flinders was also because we could be free from the disciplines. We kept the discipline. At the time we created neuroscience, by the way, but in a way, the teaching here at Flinders was already different from anywhere else because of that. We taught systems, not disciplines. And therefore, that is one of the reasons why I taught the nervous system, is one of the reasons why I claim now I have something to say about how we can bridge that terrible gap between the real stuff and the mental stuff. Now, I believe you can start this. It's a little movie. It's a pellet in an isolated guinea pig colon. This is called a peristaltic contractions, mediated by the very pathway that I showed you before. And why I mention this is because immediately after the next slide, will show that this allowed us to transform the viewing of this phenomenon in a very novel way. Novel in the sense that science really started properly as a way of recording about the time, midway 1800s, when this apparatus, the rotating drum, was invented, and in a way allowed continuous change of some phenomena to be plotted against time, and it was a graphic way as a physiological trace replacing tabulations. I use this still, by the way, in Melbourne. This was replaced then by the polygraph and now, of course, by the computers. But what I thought during this period is that just like this is a way to transform a real phenomenon in a way in which we can actually identify it, measure it, assess the time course, this is the way to study indeed any phenomenon in science, whether meteorology, whether astronomy. Traces has become the way to do. I reason that if we are in one world, limited by a proper quantum level, on one side, on the other one to the quasi-infinity of the universe, what I call the Newtonian, Einsteinian world, we exist in that. And that world, this world, if you want to describe something in this world that exists, you have to identify where and when. 4 dimensions: time, 3 spaces. We are 4-dimensional objects. We have a start, we have an end, and therefore I see that the correct way to describe the world scientifically is to be able to represent it graphically in 4 dimensions. Luke, of course, helped us to do this in recent years, but in a way this implies that anything that exists in the universe, it has to have these 4-dimensional characteristics. So you'll see later I propose that, of course, if the phenomenon of the mind, the so-called rest cogitans, are real events in the world, they have to be able to be transformed in this way. Next one. And this we did. On the left there you can see, in a way, the way of recording an individual trace. We put many transducers, we recorded many traces, but it's all meaningless in a way. This is the way that we developed at the time with Grant Hennig, my PhD at the time in the late 90s, whereby space is this way, time is that way, and the grayness is the diameter of the intestine. So this is not a 4-dimensional object, it's a 3-dimensional object. It's what we call a spatial temporal map of the movement of the intestine. So you can see now the link between the rotating drum back in 1800 to multiple traces to make actually spatial temporal maps of events, and this shows that. The next one shows that the video that someone showed you before becomes indeed a spatial temporal map, becomes a streak, the movement, where you can study the slope, the changes, everything else. So this is the way in which we developed this in the last 20 years of Flinders, and we were probably among the first. 2 other labs did something in parallel, by the way, one in Switzerland, one in France, at the end of the 1990s. So in a way you realize that I began to see the phenomena in the world as always be able to be transformed in a 4-dimensional object, which we can't, but 3-dimensional by sacrificing one. And so here, a section of this way represents a silhouette, anatomy. If I were to draw a line like that, there will be a trace, a time trace going up and down. So we wrote together a review posing the idea of going beyond anatomy and physiology, which was in the back of my mind for a long time. So you can see that now I'm trying to unify what the world in which we exist, and therefore also the nervous system in this particular way. By the way, I began to see the relation between the gut and locomotion, because I was teaching medical students locomotion of the lamprey, and Vladimir still does now. Look at this movie. This is the same as you saw before, with a pellet running down the gut. In this case, we fixed the pellet.
That's not going to go much, sorry.
It's not going to go. However, what this will show is that the pellet stays steady, and the gut walks over the pellet. So that's why I thought that the peristalsis is a form of locomotion that moved the contents instead of the animal moving in an environment. But that gave us the idea. Go to the next slide, please. Why this doesn't work is mysterious. It was working before.
Too much testing.
Too much testing. And so, in a way, we go back one step forward.
Okay, it's my turn.
Yes.
So, Marcello, you talked about one world. That's what your argument is about. You were developing these ideas in all the time that I've been here, but in 2008 there was a change. Can you tell us about that, please?
Indeed. Thank you for these very critical questions. And you're right. In the year 2000s, you may remember, you needed to become more independent from me for funding reasons. And I found myself to be alone with an assistant, and I found it very difficult to get funding. That time coincided with the arrival of a very famous woman, the director of the Royal Institutions in London, and Susan Greenfield. And I joined her in a way, and together we helped to establish something equivalent in South Australia. We do have a Royal Institution in Australia, in Adelaide. And I did many things then, including bringing together all the neuroscientists in South Australia and linking with other disciplines, philosophy, mathematics, of course neurology, but also social studies and so on. And a link with the governments, and I did a lot of things, trying to create an institute, a virtual institute of neuroscience between the three universities. Let me say that the time coincided with the push by the government to make universities more industrial-like. So they competed, and fundamentally they killed the idea. But I did learn quite a lot. And that culminated with a meeting in Hobart, the ANS, where, together with another guy from Melbourne, a very lovely person, a symposium on consciousness. Bill was there too, and I said then similar things I'm telling today, but not quite as deep and profound. But during a coffee break, the philosopher that we invited from Sydney, a Chomsky, by the way, we chatted and said, well, we're not going to find the neural correlate of consciousness yet. It's too complicated. He said, but surely you work in the gut, so you would have the neural correlate of peristalsis. And I said, no. So I decided then to return back to the labs by a series of coincidences, one of which was the arrival of Nick at Flinders, and he was working on the spatial temporal map developed by a dear friend, Gary Mauer, that left us unfortunately a few months ago. And his system was much worse than the one I developed at the time with Grant Hennig. Grant Hennig happened to be in Adelaide. He was in the United States then. And he updated my computer to his new method to make spatial temporal maps. And adding to that was the arrival of Phil Dinney visiting, and we tested in a way the rabbit column. He was working on that, and applied the spatial temporal map on one side and the intraluminal probe of pressures that they developed while it was working in Sydney with John Arkwright. They both came here, and I'm delighted that Phil C has been part of this extended team. And that brought me back, the next slide, to be part really of this extended group. You can see here, you recognize most people here. This is John Arkwright. You can see Luke there. Luke has taken the place of multiplied by 10 of Grant Hennig. Anything in our philosophical chat, he seemed to have understood everything I told him, which is very, very strange. And he developed most of the methods that we have been using in the last 15 years or more. So I was very privileged to be part of this group. If you go ahead, next slide. That's what we did. We put together the video that was already used to detect the change in diameter, apply this probe with very close recording points, and then we could study the events in the gut with not just one kind of map, but two maps. Here is, that's of course is Luke making. This represents a segment of color. Time goes that way, and in black to green is pressure, so this is the pressure maps, and black to magenta is actually diameter. We decided to then to fraction every part of a map and simplify simply by saying anything that is a contraction or change in force of the muscle is red, everything is actually blue, is inhibited. So we map the movement of the gut on the basis of the functions of the neurons, excitatory inhibitory. These represent the peristaltic contractions, confirming the old idea still of a long time ago that there's ahead of it there's a relaxation. So in a way this allowed us to study in great detail this phenomenon of movement of the gut, taking into account not just the changes of shape, but also the forces behind it. This allowed in a way to imagine the internal nervous system interacting with the muscles, moving the contents, forming a kind of a loop, a sensory motor loop. We call that intestinal neuromechanical loop. Once you got a loop, it's very hard, in fact conceptually impossible, to establish where does it start. Most of our science is that you give a signal or stimulus and you see the response. Here you can break it and you can do all that. But to understand what happened when it works in real life, there's no longer a stimulus response. There's no longer a reflex. In fact, some of the agreement years ago, there are no reflexes in real life. There are artifacts we use. This is a reflex. But my walking is not a reflex. So this implies that we cannot portray this phenomenon simply without taking into account a dynamic state. Dynamic states in my book will be the beginning of, the nonlinear dynamics and chaos theory and Jabotinsky reaction diffusion equation, which is what guides the nervous system. But it gave me the idea that this is similar to what happened in the brain. I was teaching the same thing about the spinal cord for locomotion. Next one. And then whatever you want to ask me, Simon.
Okay, so. Okay, Marcello, you've told us about your research in neurogastroenterology, trying to understand the circuitry of a bit of colon pushing a pellet. How do you link that to studies of higher functions and consciousness?
Indeed, a big challenge, which I'm not sure whether I've completed, but I'm trying to. Well, teaching the medical students, I told them that by and large our nervous system is organized this way. 3 kinds of neurons. Sensory neuron, which detects some physical change in the external or internal environment. Motor neurons, which are responsible to the kinetic changes in muscles, whether striatal or smooth muscle, doesn't matter, or secretion, but anyway. And then interneuron, the neurons in between. Mind you, I used to tell them correctly that there are only a few million sensory neurons, whether vision, touch, olfaction. There are only a few millions motor neurons. But our brain is mostly made of interneurons. People claim about 80 billions, 10 times the human population on Earth. So in a way, this allowed me to see something similar to what we saw in the intestine, which have very similar pathways. So this I call the primordial neuromechanical loop. If you go to the next slide, it shows that this idea, this nervous system with spontaneous activity interact with the external environment in the same way I was telling you before. It's a closed loop with no beginning and no end. It can start anywhere. So the state of the system is a dynamic system in time and space. This allows me to propose a very simple solution also to the philosophical problem of Descartes, of the dualism. Descartes living at the age where, mid-1600, where the physics was mostly mechanical, mostly hydrodynamic. You may remember his picture about the reflexes from mass with a pipe made of liquids. He had 2 reasons for not pushing the idea that the res cogitans was made of the same stuff. He couldn't, because the hydrodynamic could not explain the working of the brain. He correctly reasoned that there could not be enough fluid parts in the brain that will correspond to enormous numbers of ideas. He was right. And then he was criticized by his mentor, the Queen Christina of Sweden, who invited him, by the way, to go to live there. He died 2 weeks after by a cold, poor fellow. And she criticized because she said, well, how can you have this mental thing making the muscle move? Quite rightly. Descartes never answered. He had a book finished, and we never know because there's no copy of it. He was about to publish when he knew that Galileo was condemned by the church. He corresponded with Galileo. And so he decided probably not to touch this dualism because he preferred to leave the idea of animal like machines so that they could go on and study it. He was the founder of physiology. But he kept well away from the troubles. Not having the appropriate physics, in a way, helped him not to have to make a choice. It took another 200 years for electricity in animals by Galvani, discussing against Volta, who thought that the electricity was only between inorganic elements. They both developed, in a way, modern science. Galvani, neurophysiology, Volta, electricity, the batteries involved. So in a way, that story was postponed, and it took quite a long time before the appropriate physics could be thought to describe the nervous system. So the boundary between the res extensa and the res cogitans is here. And it's a boundary between two physics. One is all the physics that we know, and the other is the electrochemistry of the brain. So we do have a physics for what Descartes already thought was the site of the mind, and no one argued that the brain is the site of the mind, and the thinking and the consciousness. So in a way, this, in my view, resolved that side of the story. There's no need to keep the distinction between res extensa and res cogitans. They are the same part of the world. One is the external world, indeed, and the other one is the internal world of the brain, which is indeed is the nervous system. Then, in my teaching also medical students, it became clear that if we, from the sensory motor loop to the spinal cord, you go to the next step, you go to the brainstem, where there are centers interactive for locomotion, and then I suggest that then and now that the brain is organized as a multi-story building consisting of superimposed internal neural loops connected by pathway going up and pathway going down, and pathway interconnected at every level. And by the way, this does not have any other directionality except being a loop, up and down, up and down. And the neural circuits behave physically as electrochemical active media. Active media are made of elements which are spontaneously active. They are connected. Those who tend to oscillate, which most metabolic events, even inorganic events, you know, the petri dishes with the Belousov-Zhabotinsky reactions. How many of you have heard of Belousov-Zhabotinsky? Cost one, two, at least, I'm delighted. Belousov was a Russian in late 50s, early 60s, that actually studied the changes in the reactions when you mix reactants, color, they will tend for the Michaelis constant all the way down to complete balance. He observed that on the way there, things were changing, shape were forming, running, traveling, circulating. He could not publish that in the communist Russia. His colleague didn't accept it. He abandoned science, and a generation later, Zhabotinsky did experiments again in Russia, and at the time was more open. So in 1970-71, he published, indeed, a paper in English, and describing full these reactions, showing that even a system of, call it pure chemistry, can generate order while it's getting down to complete, if you like, complete end of the reactions. And then a famous philosopher scientist, Ilya Prigogine, in the very last decades, he got the Nobel Prize for that, kept adding, re-infusing these containers, and therefore they invented an apparatus. Then in Oregon did the same, and all the modern chemistry of active media come from there. The same equations that runs the reaction that I show you of Berezov-Zhabotinsky are exactly the same as the one that will describe fires in a forest, or the propagation reaction potential in a network of neurons. The same equations of Orchin and Huxley. So that is the link. So this physics of the neural circuits are the same as the mathematics that describe just about every single system in nonlinear dynamics, which makes the story slightly more complicated because nonlinear dynamics is telling us something important, that although the world may be determined, is not predictable, totally. And that means that every moment in the universe is new. Most physicists now accept that view. The laws, of course, requires a lawyer. There's no lawyers, so there are no laws. Rules are an approximation of what we can understand to make the world comprehensible. But if you get to the stages of the brain, which it looks like in terms of complexity and connectivity is greater than all the potential interconnections between all the stars in the universe. So if that is the case, then get ready that although I may suggest to you a way to go about, it may not be feasible in practice, perhaps not even desirable. But I'd like to give you my proposal of how we go about. Next one. I imagine in this very funny way, us as a little building going all the way to the cortex also, with also the cortex being in a hierarchical way or superimposed loops. In searching the literature about how many levels in the cortex is not been done by anyone, and it may be, in my perspective now, having read thousands of papers, in the range of hundreds levels. The very top levels may be the one of poetry, philosophy, mathematics, inventions, creativity. And then I summarize us in this little gadget, whereby all the connection between this and the world have to enter on the ground floor, sensory inputs, and everything that we can express as existing being has to come out via the output, which is our motor neurons. So this put us further and further and further and further away from the external world. This extra dimension of many realms is something added to the idea that we have a world made of layers, from atoms all the way to galaxies to us. So this part of the brain has the same layering from molecules to cells as the bottom one. But the features of these levels, at every level, they add new properties. People call about emerging properties, just like everything else. Just like molecules put in a particular way may form a cell, and a cell is not just a bunch of molecules, but the architecture of it gives them a particular feature we call living cells. So this same issue of finding the nature of life, to me, is to find the nature of the activity up there. Now, these superimposed loops are in evolution and during our own individual life, and are associated with higher mental function as we go up, with increasing distance from the world, from automatic behavior, sensation, perception, cognitive feeling, high mental functions. How many layers, I don't know. There are certainly more than than the tree that a very good colleague that also Bill Blessed knows very well, Joseph Ledoux wrote a wonderful book last year, by the way, talking about the four realms of existence. The world, the neurobiological world, the cognitive world, and the mental world. And I agree with him, but I put many, many, many more. Plus I'm trying to give it, I call it an anatomical statement, that there is some anatomical reason to think this way. One consequence of all this, by the way, is that we can only communicate this way, at the ground level. You hear me because I express a voice that comes out as a sound, you hear a sound, and it's interpreted with a bit of luck in English. If I were to speak in Italian, probably nothing would happen there to you. Yeah. So in a way, you see, this is also a humbling limitation, that we can only know something by sharing it. And I may comment now that this is the very issue about the essence of objective knowledge. Because behind the idea of Descartes, he can know something about the world together is objective, but what's inside us is personal, is entirely individual. Well, as a matter of fact, now most physicists accept that, and certainly I hope most physiologists, every bit of knowledge, every bit of experience is personal. And the fact that you can see this picture and hear what I'm telling you about it is because we share the same neural machinery that allow me to think about us like a little gadget there, and you to understand it and interpret the same way. A dog and a monkey would not be able to do that. So what we call objective is simply the ability of rendering and sharing the experience. We can share experiences, even personal ones. And people are doing this all the time, and increasingly so, and society allows that increasingly. So the so-called introspection has become a valid tool to study, indeed, the state of the mind of other people. There's no longer an argument. It's a question of methodology and validation. Next one. Having also said that we live in a four-dimensional world, how do we live in it? Well, we live it only very narrow, not only space, we can see the sun and so on, but time-wise, we live in the present only. St. Augustine, in the first millennium, claimed that the present does not exist. I think he was wrong. I think the present lasts. We don't know how long because it has not been studied, but probably a few seconds. So we have a little window. We stopped working as well, but doesn't matter. The time window is where we live. We only live in the present. What I just told you 10 seconds ago is past memory. What I didn't tell you yet is not there yet. It's in the future. This represents, in my view, also a humbling realization that not only we exist in this world by interacting directly at the ground level, both way in and out, but this interaction occurs in a very specific time. You can decide you're going to do something, but you can only do that in the present time you do that. One consequence of that is that the time must be significant in evolution. What could be the time? My view is go back to locomotion, to escape reactions. The time of the present for an animal, including us, is the time within which we can permit an action or stop it. And I remember this well. My good wife is scared of snakes, and she always sees them in the wilderness. And we were walking in the wilderness of Victoria once, and I almost put a foot on a big dead adder that was crossing my path. And I delayed by a fraction of a second to put my foot. Similarly, coming back from climbing Mount Matterhorn, Cervino, which is the same word in Italian and in German, I went up to help two colleagues that were guides at the time. I used to be an assistant guide. I stopped climbing, by the way, because my assistant in the school of climbing in Turin died together with students, and my replacement because I was homesick. So being sick is not always bad. But coming down, the guides don't tie themselves to each other. They were very, very aware of the tragedy of Whymper, the first one that together with Sir Fries from England climbed Matterhorn. On the way down, 10 of them died because two fell and they took the other one down with the ropes. So the guys don't tie themselves to each other when they come down. So I descended the Matterhorn 6 hours without any security, sometimes climbing down backwards. And that I still remember now. I remember that every step is a step of life or death. So in a way, the idea that we live in the present, that present is the only time when you can act by doing or not something. We know that the humans do have some control. We have a sense of control. Whether we have it or not in the true philosophical way, I don't know. We have plenty of internal drives, we know, and then the upper part of the brain is almost like give permission, the frontal lobes, that tell you, yes, you can do this, or no, stop. This is the reason why we don't want powerful people with a button with atomic bombs. That's the reason. And the next one, I think, might give me this idea. Given that we live and can only act in the present, we are responsible for what we do or don't only in that moment. If I've done something wrong, we can be judged for what we did. But we can only be ethical in the moment that we do things. That's the world of ethics. So every one of us, in every moment we do, we can do something that is desirable or not, acceptable or not, moral or not, I don't mind, but it's only in that moment that you can do it. And if you take that view, then if you think, I saw a lovely documentary on SBS of the life of Netanyahu, who, among others, may I say straight away, is a criminal, because he, every day, presses the button for actions which are actually inhuman. In that moment, he does a command to send his army, to send whatever. He's a criminal. He's guilty. Every time, similarly, in parallel to an extremist Islamic that decides that has to kill any Jews and does it, or send a message to do it, is ethically responsible and is guilty like hell. That's the only form in which I regard morality and ethics. The idea of this superimposed loops all the way to the cortex is not entirely mine. It was proposed by Fuster. And you see again the distinction between the dorsal, sensory, ventral, motor, and even the cortex, and see how you go from the primary to the association to the polymodal. So this is simply just a reminder that what I'm saying, it has a fairly good support from the previous studies. Hopefully you can run this movie, because now I come to the idea, how do we portray the activities of the brain? This is a bit of a isolated cortex. You can see there at the top, you can see the little square there in the middle. That corresponds to this trace. See going up and down? It would be a traditional way of recording, let's say, an electroencephalogram. This now is a full spatial temporal map as it happens. You can see the shapes, spirals. These are practically repeatable and calculated by the same rules of the Belousov-Zapotinsky reactions. This is neural activity. These are the oscillating systems of the active media that I was telling you, electrochemical physics of the brain. So in a way, this tells us that we can record the activity we could make of this. The next slide shows that a similar preparation, you begin to see streaks, a bit like our peristaltic contractions, special temporal maps. This represents a state of the brain when it's actually activated by the cholinergic active. Now, would this be the nature of the thing? No, because this is isolated the cortex without the interconnection, without sensory inputs, without the feedback of motor outputs, and this may well represent, could be even an epileptic fit. But this shows that we can, in principle, create spatial temporal maps of brain activity, which is the way to represent physical phenomena in the world in 4 dimensions. It's against only 3, because you can only have time, space, and some color of activity. But conceptually, you understand me, that this is the proper way to portray the world, not just the gut, not just meteorology, which this is done all the time, not just metabolism, not just fires in the wilderness, but also brain activity. Would we be able to, in the future, to do that for the various multi-levels to which we are ascribing the mental activities? People are trying, but they are not putting this philosophy, practical philosophy, I'm telling you, yet. They are trying to do something all simultaneously. The theory of mind now are, in my view, going in all directions. My view, that until they realize that this is the way, that will happen. Will it be desirable to happen? Well, like all the limitations, yes, to some degree. Is it possible to detect whether I'm now thinking of my expedition in Patagonia? One can say, who cares? Why should anybody extract from my brain a special temporal map of what's happening across my mind now? We know that the human mind wanders all the time. We have ideas, we have thoughts, expectations, emotions. Well, for those things that people will want to study and finding the scientific way to study it, this is the way to go. We know that there are 8 billion people on Earth with mobiles. If you are on the moon and you detect the activity of an electrical mobile, you go up and down night and day. Okay? You got oscillations, like in the brain during sleep. Who cares? Somebody will, I'm afraid. What is 8 billion people are talking to each other with a mobile every moment. To do the same for the brain would be having 80 billion mobiles to portray in this way. So it may not be feasible in practice may not even be entirely desirable for personal reasons, but in many cases, yes. People want to know what the corresponding state of depression, excitement, obsessive compulsive disorders, and so on. Of course we will do that. We want to bypass the limitation of our brain that needs to come out. They do that already. Elon Musk is already doing that, and other people do. Detecting the activity of your premotor cortex, reading your intentions to move, and using a robot. So you can see this is the way that people will have to go if they want to relate a state of the brain with a corresponding state of the mind. State of the mind, we come, I think, towards the end here. I just told you this now, so let's keep going. Mapping this path of neuroactivity in time and space is equivalent to define the four-dimensional physical structure underlying the brain processes. And constructing, therefore, this means that we can represent in a mental state, including conscious experiences, and therefore will make conscious experiences part of the same world as the external world. Will be able to be shared, investigated, studied, and therefore we are in that direction. So the idea of unifying the world in one, I believe in my own internal feeling that I have achieved that. As the system becomes complex in more layers, it's not entirely by chance. Evolution has given some advantages, because as we go up in levels, it looks like our existence, the horizon of existence also increases. So we think about the universe, we think about mathematics, we think about the consciousness. So the increasing of the horizon goes in parallel with the increasing of the number of loops up there. So this is one of the advantages, which I'm going to tell you next. Better, I will.
Actually, I'm going to interrupt. So these horizons of existence, they accumulate as we mature and as our brains mature. And you're suggesting that we broaden that. How is that possible?
Well, the broadening is already what happened in evolution. As an animal like a lamprey not only senses its own movements at the spinal level, has also visual and balance inputs. So the horizon of the lamprey increases compared to a worm that does not detect that. So having a system of some loops on top of the original ones, it also means that you're extending the horizon, because even a dog has an experience of being in space without thinking. And therefore that state of being in a space and time is created by the existence of those loops. If you only had a spinal cord with locomotion, you wouldn't have that internal feeling. So as the loops increase, the level of feeling of the world enhances, broadens. There are traps. I think I may be able to talk about the traps in a moment.
Can we ask questions from the crowd? How do you think...
No, sorry. Question, if you want to ask a question, come and use the microphone here, please.
Yeah. Sorry, I'll ask later.
Yeah.
That's okay.
Keep the question, come, because we need to record you properly.
Okay.
So, having this enormous ability to have increased the horizons, we must construct the world view still based, as we are doing every moment, on a direct experience in the idea of the world, experimental science, the external world which we are doing, the social world which is beginning to be, in our own inner world, which I'm suggesting we can do. The world view I described strongly recommend us to use our own creative imagination, which is part of this enormous ability of the brain based on memory, imagination of the future, to continue to explore the external and internal world. Such exploration should benefit human existence by solving problems, reducing suffering, while doing no harm to others, to ourselves, and to the environment. This view should enable a constructive creativity to be expressed at its best, making every individual free, allowing to expand the world. Independent means not too subjected to external and internal drives without being aware of, and therefore responsible for that moment in which we can all act. The social environment that fosters this aim includes sustaining civil and social rights. I say all this because it's implicit to allow the system I'm telling you to develop properly within the best invention parliamentary democracies, separation of power and freedom of expression. The pleasure we experience from art and music represent the purest expression and creation of these internal neural loops. This pleasure I want to highlight because I use music as an example. The dark side of our imagination in developing this broadening of the horizon, when they're not brought back to the loop in our connection with the world, but testing it is reality. They are myth, religious cosmologies, absolutist ideologies that represent imagination not constrained by any test of reality. They remain dangerous dreams endangering the very survival of humanity. I say this because this is a consequence, in my view, of the very structure of the brain I'm proposing. Keep going. This has been my marvelous feeling of having recognized as a success, my book. I can finish now. I was ending with something that I missed. It disappeared the slide. Music. I was going to show you that I play music, classic music, guitar. I play jazz in Italy. I sang in a choral society of classic music. I play at the governor's house many times, and I was singing until last year in an Italian folk ensemble. Why do I make music the peak of our horizon experience? Apart from being a good binding between people, music represents pure pleasure without doing anything useful. Why? Because all the abilities that humans develop above animals have to do with the connection between parts of the brain. We can break our movements, we can march and while we are cutting, we can work together, we can escape, we can hunt, our basal ganglia. So we are neural machines. We have the maximum possibility of connecting different parts of the brain. And music does that. Music activates all the possible parts of the brain that can be connected, which dogs don't have, monkeys probably not. So that is why playing music is walking, locomotion, marching, singing, beating, producing sound instruments, singing, seeing each other. All that are all those abilities of evolution clustered in one action, completely useless except the pleasure of being humans together. And that's why I think that I can end now indeed. Thank you all for all what you've done, and I hope I'll still be able to do. Thank you so much.
Thank you,
Last question,
Marcello. We'll take questions in just a moment. If there's anybody who has to leave now, given the time, this is the time to do it. Otherwise, stick around, and we've got questions till 6:30ish. So, Damien, you wanted to start off?
Yes.
Come and grab the microphone so we can record your voice.
Just, the question I had at the time, Marcello, was your concept of horizons was very interesting, and you talked about it in terms of being across species and what might separate aspects of cognitive function. I wonder if you have thoughts on whether or not it could apply within species, and if we think about that in terms of humans, an example might be in terms of different levels of intelligence.
Yeah, thank you, Damien. That's a very good question. Oh, yes, that's fine. Yes, of course, there's a lot of literature about comparing human and animal brains. This book I was telling you about, Ledoux, he clearly claims that of the three neurally based realms, only part of the very top is only human. It has to do with the middle frontal lobes. Everything else that has to do with some mental activities, cognition, is shared with animals. And therefore the change probably happened, we don't know exactly when, but it has to do almost certainly with language. And language is what probably changed dramatically the way in which those upper loops are able to operate, and animals don't very much.
Marcello, when you were talking towards the end, I was really wanting to ask a question about your diagram of the little gizmos that you had with the multiple levels. Those levels suggest something that is quantized into different discrete levels. Is that what you believe, or is that just a model? Is it possible that there's actually continuity between some of those levels?
Well, let's put it this way: if there is an anatomical base, then there are jumps. And by the way, I tend to think about measuring those jumps as a number of synapses from the external world.
Mm-hmm.
So if you ask me how many jumps you go from, for instance, the visual primary cortex to the cortex association which detects faces, color, movement, shapes, looks like there are jumps which are all or none. But if you go further up, you arrive to the angular gyros that join in a way the temporal, visual, and occipital visual and sensory primary cortex. There you have the very famous Wernicke area that in 1800 was the one that found a lesion, people not able to read. But then there must be some areas which we know of which are dedicated to English. If you learn English and another language at the same time, they overlap. If it is like me, first I learned Italian when I was a child, teenager Spanish, and adult English. Evidence will show that I have 3 little areas which are separate. So a lesion there I could lose my English, but not Italian. So how far you go there the jumps are probably very many more. And your question, therefore, are really all of them all or none? The answer would be yes at every level, but the level may be very subtle. So, for instance, from understanding a theorem of Pythagoras or not, I suspect there's a jump. Physically, how far away they are in the area of understanding mathematics, I don't know, but I suspect there will be some gap, and therefore thing will be in a state or another. Not quite, but similar in a way to sleep. That you can actually jump the level of sleeps all of a sudden, and I suspect if you come to an idea, whether you have an idea or not, may be a jump from one level to another, I suspect, but I don't know.
Any other questions? Please come out and use the microphone.
I just look up very quick, Marcello, about your idea of ethics and present moment. So I'm a little bit struggling with that because, as you know, consciousness awareness comes a little bit later. So we do something, and then there is a delay, 100 milliseconds or so, that we actually understand that was our conscious moment. Okay,
Yes.
so that's why I'm a little bit struggling. If you have a very simple example, a killer trying to kill somebody and he just pressing the rifle, he will be only aware about that movement 100 milliseconds later.
True.
But in order to prosecute him, you need to look on that premotor cortex and record his planning activity. So that's why ethics, in my opinion, should apply a little bit before the event.
Yes, I understand very well what you're saying, Vladimir. It is right that we seem to have an internal motivation that drives us moving even a finger that happens before we actually are aware that we want to move the finger. And that lasts 300 milliseconds. So those 300 milliseconds are not under our control. Okay? That's why it's dangerous to have it. We often do in computer, you press it, oh shit, I press the button. Anything that's later than the 300 milliseconds that becomes the present, then you can stop it. And therefore, that is the moment in which, in my view, you should be judged for what you have done. What you intended to do could be morally reprehensible. As I say, you have an internal drive that tells you that you should kill, if you're Russian, it tells you should kill all the Ukrainians. Then you have already an internal drive which is extremely dangerous, and it makes you a slave of your actions. You're no less responsible for the action you do in the moment you do it. And you can condemn the motivations, but your action is the only time you could stop. And if you have the motivation, being a Russian soldier, and you do not kill somebody else when you could, then that's your freedom.
Wow. Nick, can you come out so that we can get you on video?
You see, we need to record everything visually. And
thank you very much. I feel like I'm talking now. Thanks for your presentation. You didn't mention the anatomy of consciousness. And my many hours of talking with my great mentor, Bill Blessing, humans are still searching for the anatomy responsible for consciousness in humans. Why are we struggling to do that? And what makes a simple invertebrate like C. elegans conscious or not?
well, in my books, I understand a lot of this stuff, of course. The fact you can go and probe physically, electrically, or chemically different parts of the brain and change the state of consciousness is a way to investigate where and how that happens. If you, I mentioned before that this book of Ledoux goes in great details where he talks about the upper path, the top realm. He attributes the sense of self-awareness and self-consciousness and Tom or others to this medial frontal lobes, a little area, which is connected. So how it's so hard to study is because not knowing where these levels are, at the moment we simply do not have the way of recording time and space-wise to construct special temporal maps, not only at one level, that would be hard enough, but if you want to understand the whole system, I should mention that again, everything works always in parallel. All the levels that we have work always in parallel and at the same time. But if you want to attribute a particular state, you have to go to those levels from which the states depend. At the moment, the methodology is not there. Electrophysiologically, yes, to some degree. The functional MRI is not fast enough to follow events millisecond by millisecond. It's about to happen. When it will happen, and when people will be able to go and cut sections and separate them, then you have not just a special temporal map of one level, but all levels on top of each other. The physics of that has not even yet been conceived. The method that people will have available, by the way, exists already, and is using in artificial intelligence, and has been the very method, mathematical method, was developed by Paris, the Nobel Prize of Physics in 2 years ago from Italy. Paris, a professor of mathematics. He developed a universal method to study complex systems, whereby no matter how many layers you have, you can actually study the interactions. But neuroscientists are not yet even thinking of that. I hope that my book will encourage them.
Any more questions for Marcello? Perhaps I've got a on, please.
Thank you. Really wonderful lecture.
Come.
Yeah, really wonderful lecture. My question relates to the loops of neural circuits and how you see in this system the phenomenon of memory.
Of memory?
Yes.
Well, that is actually an area that I don't touch too much in my book because it's reasonably well known. As you know, we have actually, people talk different memories, immediate memory, working memory, medium-term memory, long-term memory. It looks like that we begin to have memory in the hippocampus. In the hippocampus, that's where the memory of space around is. Animals build the maps of space of that. And together with that, also time, the time it takes for them to move around. From there, they seem to connect to the rest of the brain, particularly frontal lobes. And there, you're right, somewhere, somehow, become a long-term memory. And how it becomes term memory is not entirely clear. Eric Kandel, the Nobel Prize for Medicine, he got the Nobel Prize for having found the molecular mechanism of memory in an invertebrate, at a synapses. And then he kept working, of course, in trying to understand the human memory. And here the colleagues discovered something which is not very clear yet in literature, 15 years ago at least. He thought and had evidence that the translation from working memory, short-term memory, to fixed memory is using particles which actually been transferred from cell to cell, just like viruses. In evolution, he talks about the idea that some viruses became the transporter of information in the DNA. And so paradoxically, our memory is really fixed, will become permanent or semi-permanent by having been transported by virus-like particles. So that was an extraordinary idea that I didn't see much more done about it, but that's my understanding. But the fact that it started in the hippocampus and then spread from there, that's well known. So if you damage the hippocampus, you lose not only memory, by the way, but also the ability of imagining the future. And so that's why I link the past and the future, and therefore the so-called working memory, it has to do with a little extension of the present, which allowed you not only to do step by step, but to do 10 steps. Horses have that. So in a way, there's a gap that the hippocampus help. So the memory is like an extended present that allowed the animals to change directions, but the action is still made in the present, very narrow.
Okay, I've got one very short question, which I hope will get a very short answer. Can one interneuron be part of two loops in the brain?
Yes, absolutely. At every level, the neurons are part of internal, if you like, connections, and the same neuron can go to the other side, the descending side, and the same neuron can send a message up. In fact, that's the origin of the idea of multiple layers, because when I used to teach the students, and you do that too, pain, you ask a student, you put your finger on a flame, you remove it. Why? The answer is usually because I feel pain. The answer is not. Vladimir agreed with me, you're teaching this now as well. Because the primary sensory neuron that detects the burn will synapse with one or two interneurons in the spinal cord, activating what we call the withdrawal reflex or the escape reaction. That happens before the same sensory neuron that enters in the spinal cord is sending up in the dorsal column a pathway all the way up to the brainstem, to the thalamus, and to the cortex, where you do feel pain. So you feel the pain later than the removal of a finger. So much so that if you're paralyzed, that reflex of removing the finger is enhanced. So you still withdraw the finger, but you don't feel pain. So that's the answer. So a single neuron is part of multiple loops.
And on that note, I will call things to a close. So I'd like to thank Marcello for what has to be one of the most stimulating talks I think most of us have ever heard. Thank you, Marcello. And there are drinks available, and I think some snacks too, to revive the spirits.